Hi friends, we'll solve problem on curvilinear motion. See what is given in problem. A particle at the position 4-6 meters at start is accelerated at a equal to 40 I minus 10t square j. Determine the acceleration, velocity and displacement at t equal to 2 seconds. As in problem A is given as 40 I minus 10t square j, means this acceleration is always in the form axi plus ayj. That means here acceleration what is given, a equal to 40 I minus 10 t square j. 40 represents component of acceleration along x-axis and 10t square is ay. Therefore, this ax is equal to 40. Say equation number 1. From ax, we'll find out what is vx and what is the position ex. You have to integrate this equation. Therefore, ax will write as what? Ax is written as dvx by dt, which is equal to 40. Therefore, dvx equal to 4t dt. Now, if you integrate this equation, so what will get here? Integral of dvx equal to integral of 40 dt. Integral of dvx is vx. Integral of 4t is 4t square by 2 plus say constant of integration c1. Now what is given? Boundary condition means initial condition at t equal to 0. Particle at the position 4-6 at start is accelerated. That means initially velocity of particle is 0. Therefore t equal to 0, vx vy both the 0. Here vx is 0. Therefore c1 equal to 0. At c1 is 0, equation of vx comes out to be 2t square plus c1 0, equation number 2. Once we will get equation of vx, if we will write vx as dx by dt, now from this one again 2t square, therefore dx equal to 2t square dt. Now if we will integrate this equation, integral of dx equal to integral of 2t square dt. Integral of dx is x. Integral of 2t square is 2t cube by 3 plus different constant of integration say c2. Now what boundary condition or initial condition is given? Particle at the position 4-6 meters at start. That means at t equal to 0, x equal to 4 meters. If we substitute this t equal to 0 and x equal to 4, what will get from this one? t0 to this term comes out to be 0, will get c2 equal to 4. Therefore, equation of x is written as 2 by 3 t cube plus 4, equation number 3. That means we started from this ax, from ax we are getting vx, again we will integrate it, we will get what? Ax. Similarly, what is given? Minus 10t square j, that means ay is known. From ay we will find out vy, from vy we will find out y. Ay is given as minus 10t square. We will continue on next page. So what is known? Ay equal to minus 10t square. Ay is minus 10t square. Say equation number 4. Now if we will write ay in terms of velocity is dvy by dt equal to minus 10t square. That means dvy comes out to be minus 10t square dt. If we integrate this equation, what will get? Integral of dvy is vy. Minus 10t square if we integrate, minus 10 t cube by 3 plus some constant of integration c3. Initially particle starts at t equal to 0. That means what condition is given is t equal to 0, Vy is 0. If we'll substitute this t as 0, Vy is 0, what will get here? C2 equal to 0. Therefore, equation of Vy is minus 10 by 3 t cube. Say equation number 5. Now if we'll write Vy as dy by dt, differentiation of y with respect to time t is Vy minus 10 by 3 t cube. Therefore, dy equal to minus 10 by 3 t cube dt. Now if we integrate this equation, we will get here y equal to integral of minus 10 by 3 t cube is minus 10 by 3. Integral of t cube is t raised to 4 upon 4 plus different constant of integration c4. Initial position what is given is 6 meters at start. That means what condition is given? At t equal to 0, y equal to 6 meters. If we substitute this condition in equation of y, what will get here? Y is 6 meters, t is 0 plus c4. Therefore, c4 value comes out to be 6 meters. Therefore, equation of y is equal to minus 10 by 3 into t raised to 4 upon 4 plus 6. That means this minus 10 upon 4 into 3 is what? 12, t raised to 4 plus 6. Equation of y. Say equation number 6. Now what is asked in problem? Determine acceleration velocity at t equal to 2 seconds. Displacement also at t equal to 2 seconds. We'll substitute t equal to 2 seconds in equation of first acceleration. We'll get resultant acceleration. Again we'll substitute in equation of velocity. Therefore at t equal to 2 seconds, first this is ax number 1 and this is ay. We'll substitute these values and from this one we'll find out what is ax and ay at t equal to 2 seconds. Therefore, next step is what? Substituting value of t at t equal to 2 seconds. What you will find out? First one is ax. To find out ax, you know equation of ax is what? 4 into t. 4 into t, t is 2 seconds. That means what will get here? 8 meters per second square. Answer positive means right word. Similarly, ay if you want to find out, we'll substitute again t equal to 2 seconds in equation of ay. Ay equal to minus 10 t square, that means 2 square. Therefore, this value comes out to be minus 40 meters per second square. As we are getting negative answer, what it represents? 40 meters per second square, direction downward. This one is downward. Once we will get this one, so ax is 8 meter per second square, ay is 40 meter per second square. From this one, if we will try our resultant acceleration will get in third quadrant, ax rightward, ay downward. Therefore, resultant acceleration you will get in fourth quadrant. If we will represent here resultant acceleration, it is a magnitude of this acceleration we will find out applying Pythagoras theorem. Resultant acceleration, inclination I will write as theta suffix a. That means inclination of acceleration with horizontal. Magnitude of a equal to square root of ax square plus ay square. If we will substitute here ax as what? 8 square plus 40 square, this resultant acceleration will calculate using calculator, comes out to be 40.79 meters per second square. inclination theta A, if you want to find out, tan inverse of opposite upon adjacent, that means tan inverse of AY is what? 40 divided by AX is 8. Therefore, angle theta A comes out to be, calculate using calculator, 78.69 degrees. That means final what you are getting, resultant acceleration 40.79 and its inclination is what? 78.69. Now we'll find out velocity at t equal to 2 seconds. To find out velocity, as you calculated acceleration and theta A, we'll find out Vx and Vy at t equal to 2 seconds. Let's continue on next page. At t equal to 2 seconds, Vx, if we'll find out, Vx comes out to be, equation of Vx is 2t square. If we'll substitute here t equal to 2 seconds, this comes out to be 2 into 2 square. That means 2 square is 4 into 2 is what? 8 meters per second. Answer positive. That means Vx rightward. Similarly, Vy, what we are getting Vy formula using integration is minus 10 upon 3 t cube. Therefore, this value minus 10 upon 3, t will substitute here as what? 2 seconds, 2 cube. If we calculate using calculator, what will get? Minus 26.67 meters per second square. Negative sign represents what? This velocity component is in downward direction. Therefore, Vy is 26.67 meters per second in vertically downward direction. Once you will get Vx and Vy, resultant velocity if you want to find out, Vx rightward, Vy downward. Therefore, resultant velocity will get in fourth quadrant. If we will represent resultant velocity, say V, inclination of velocity, already is theta, suffix V, which represents inclination of velocity with horizontal. Magnitude of velocity, if we will find out, we will use again Pythagoras theorem, square root of Vx square plus Vy square. Vx we are getting as what? 8. So this one is 8 square plus 26.67 square. Magnitude of velocity comes out to be 27.86 meters per second. Once we will get this velocity, next important part is inclination. To find out inclination, again tan of this angle theta V, opposite upon adjacent. That means theta V, if we write, this is tan inverse of opposite is Vy, adjacent is Vx. Therefore, tan inverse of Vy, you know 26.67 divided by Vx is 8. Therefore, angle theta V, if we calculate using calculator, comes out to be 73.3 degrees. That means you are getting resultant velocity, its magnitude 27.86 meters per second and inclination as 73.3 degrees. Again you have to find out what is the position at t equal to 2 seconds. We'll find out. From that we will get displacement. Actually what is asking problem, what is displacement of particle at t equal to 2 seconds. For that one we have to find out what is the position at t equal to 2 seconds. Let's continue on next page. What will get here, at t equal to 2 seconds, if we will find out what is the value of x, I will write that x with suffix 2. What it represent? Position at t equal to 2 seconds. Formula of x, what we are done, what we are getting here is a 2 by 3 t cube plus 4. Therefore, if we will substitute here value of t as a 2 seconds, the 2 cube plus 4, this value comes out to be 9.33 meters. Once we will get this value 9.33, y value also will get substituting t equal to 2 seconds. If we will substitute here, This is minus 10 upon 12 t raised to 4 plus 6. Now here t equal to 2 second, if we substitute, it is 2 raised to 4 plus 6. That means this one is negative, therefore answer what will get here negative comes out to be minus 7.33 meters. But what you are getting, these are position at t equal to 2 seconds. If you want to find out what is the displacement, displacement is always final position minus initial position. Therefore displacement along x-axis, if you want to find out, it is final position at t equal to 2 seconds minus initial position at t equal to 0 seconds. We will write x0, x2 minus x0. x2 you have calculated 9.33 and x0 initial position is given as 4. Therefore, what we will get here 5.44 meters. Answer positive, that means the displacement is in rightward direction. Similarly, displacement along y-axis if we find out, final position means at 2 seconds, initial position at 0 seconds, final position is minus 7.33 and initial position means at t equal to 0 second, what y is given is 6. Therefore, you will get minus 7 plus 6 is 13, minus 13.33 meters. But as answer is negative, in vertical direction, particle moves in vertically downward direction. Now if you want to represent final displacement of this particle, along x-axis particle moves in rightward direction, this is delta x. Particle moves in vertically downward direction, say this one is delta y. Therefore finally what displacement will get of particle at t equal to 2 seconds, if we will represent, that is in fourth quadrant, this one is displacement, say delta r, and inclination I will write as a theta r. That means you can say it is a position vector. Now delta r, if you want to find out, it is again Pythagoras theorem, square root of delta x square plus delta y square. That means if you substitute value, delta x is 5.44 square plus next part is 13.33 is a delta y. If you substitute here, if you find out, you will get final displacement as 14.356 meters. Inclination, if you find out, delta theta r, that is always the tan of this angle, what you know, opposite upon adjacent. Therefore theta r, if you find out, this is tan inverse of delta y upon delta x. If you substitute here delta y and delta x, delta y equal to 13.33, delta x equal to 5.44, angle theta r comes out to be 68.21 degrees. That means finally you are getting displacement at t equal to 2 seconds in magnitude and in direction. Thank you.